weapons, tactics, and materials used in warfare in 2040 may now be taking shape, with a quiet, intensely focused group of Army Research Laboratory scientists now testing and manufacturing materials in anticipation of uncovering paradigm-changing new weapons and technologies for war. Army Research Laboratory. The focus of our research is to non-destructively evaluate the microstructure of materials to get full three-dimensional information that lets us determine optimal processing conditions to engineer better performing materials for the soldiers. We understand the critical information about defects, their size, their location, their shapes, and we can minimize those defects by adjusting processing conditions. Dr. Jennifer Seitens, materials engineer, Army Research Laboratory, told Warrior in an interview. We look at metals, composites, ceramics, polymers, ceramic armor, and energetic materials. Much of this scientific work includes pure creativity and visionary thinking, wherein ARL experts simply innovate by exploring new layers, mixtures, and configurations of materials at the microscopic level. Seitens explained that many of the techniques not only include the use of different combinations of materials, but a continued exploration of how materials are engineered. We are looking at adjusting the processing times, the temperatures and pressures, and we're also altering the compositions, Seitens told Warrior. Much of the process itself is referred to as additive manufacturing, wherein materials with specific value-added properties are mixed, blended, and produced together in layers. Dr. Nicholas Koo, Army Research Laboratory materials engineer, Ceramic and Transparent Materials Branch, Army Futures Command, explained this process to Warrior, saying that the volume, composition, and layering of materials, such as silicon carbide, can be adjusted in search of new combinations with improved properties. Results of this kind of innovative work, while described in terms of basic research aimed at decades into the future, also generate shorter-term value in some instances as well. Much of the research is done at the microscopic level, using various applications of nanocomputing capable of generating three-dimensional images smaller than a single strand of hair, Seitens added. This gives us the microstructural components related to how materials are made and also gives us information about their performance, she explained. The work being done by Seitens, Koo, and other scientists may well determine the material composition, design structure, configuration, and performance parameters of tanks, body armor, infantry vehicles, soldier helmets, guns, and even ammunition in the year 2050. For example, while closely examining a three-dimensional X-ray of a rotating soldier helmet, Seitens looked over a mini-wall of computer screens to analyze the properties and performance specifications of experimental materials being used to uncover optimal designs for weapons, vehicles, and soldier gear in the future. We are analyzing three-dimensional information. We can evaluate the internal structure of that to ultimately improve performance for the soldier, Seitens, materials engineer, DEVCOM Army Research Laboratory, Army Futures Command, told Warrior in an interview. The concept is to clearly innovate, with combinations and layers of novel materials with the aim of analyzing their properties. Once performance parameters can be identified, then scientists are naturally much better positioned to architect weapons for the future. The process involves analyzing combinations of substances at the microscopic level and creating, manufacturing, and producing new, better performing materials. We are using advanced manufacturing techniques to enhance the ballistic forms of armor, Dr. Nicholas Koo, materials engineer, Ceramic and Transparent Materials Branch, told Warrior in an interview. A lot of academic work has shown if you do control the way these composites are assembled, you can see how cracks initiate. You can see how layer structure can make a material tougher, Koo said. Different materials, of course, have different properties and can be manufactured in different combinations to experiment and search for groundbreaking developments wherein new materials are discovered. Perhaps new mixtures of compounds can greatly reduce cracking or penetration in a manner that outperforms traditional armor. That could lead to safer or more lethal armored vehicles, stronger, more bullet-resistant soldier helmets, or paradigm-changing high-speed kinds of ammunition. All of this innovation invites a question that lingers in a mist of uncertainty alongside the many unknown variables of armored warfare in the 2040s and 2050s. Will heavy armor still exist or be supplanted by faster, more expeditionary, lighter-weight alternatives? Could future alternatives offer Abrams tank-like protection at a fraction of the weight? Some of this may remain unknown to a degree, yet it is a challenge fully embraced by teams of scientists at the Army Research Laboratory at Aberdeen Proving Grounds and who are now conducting the basic research necessary to prepare for warfare in the 2040s, 2050s, and beyond. Questions and explorations of this kind are of great consequence to the Army, which now appears to be following an integrated, twofold path toward the development of future armored vehicles. In one respect, the service seems to recognize that there just may not yet be any substitute for heavy armor in major mechanized combat with an enemy wherein armored vehicles will need to absorb some measure of incoming enemy fire. Perhaps lightweight composites may not yet be operational to the degree that new, much lighter-weight materials could equal the protective power of heavy armor. However, such breakthroughs may not be far away, and it seems clear much progress is likely to have been made already. As part of this, it is also quite clear that the Army is committed to a lighter-weight, faster, and more expeditionary combat future, wherein armored vehicles can move quickly alongside advancing units, cross bridges, and deploy from Air Force C-17s or even C-130s. New armor compositions discovered by ARL scientists are likely already woven into new vehicles and informing prototyping for the future. While some of the specific near-term material compositions might not be available for security reasons, Army weapons developers do regularly describe how promising composite materials are being woven into armor enhancements for both existing and emerging vehicles. The maker of the Abrams tank, for example, is closely aligned with the Army strategy, as it is both heavily invested in upgrading, improving, and sustaining its tank platform while simultaneously embarking upon internal research to innovate, identify new materials, and support the Army two-pronged mission. General Dynamics Land Systems is conducting and supporting a range of innovative research aimed at addressing and even anticipating Army requirements. For instance, GDLS is working to identify new higher-performing materials capable of offering protection and survivability comparable to an Abrams tank at a fraction of the weight. General Dynamics Land Systems is involved in several external R&D efforts targeting capabilities to help our soldiers be safe and effective on the battlefield of the future. Kevin Bonner, Chief Technology Officer at General Dynamics Land Systems, told Warrior in a statement. What's interesting about this is that even if new materials were proven in ways currently unexpected, that does not mean heavy armor or platforms like an Abrams tank will no longer exist. By contrast, the Abrams is a key example of how ongoing innovation has continued to upgrade and change the platform to improve protection, computing, lethality, and combat performance. It seems conceivable that there may indeed be a place for an upgraded Abrams for decades into the future, as a platform to support and fight alongside lighter-weight, faster armored vehicles and unmanned systems. The now emerging M1A2 SEPV4 variant, for example, includes paradigm-changing, third-generation forward-looking infrared, FLIR sensors, advanced multi-purpose ammunition, new armor materials, onboard electricity, and an entirely new generation of AI-enabled computing, electronics, and command and control technologies. While timeless in certain respects in terms of its concept and basic configuration, the Abrams tank of 2022 is an entirely different platform when compared to those which emerged in the 1980s. The Army's optionally manned tank, for example, is still very much in its conceptual phase. Weapons developers are now working on various concepts, and service leaders plan to solidify a general approach by next year. Ultimately, the direction chosen for this yet-to-exist future combat vehicle will be informed, if not determined, by the measure of progress demonstrated in the realm of lightweight armor materials. Can something at a fraction of the weight of heavy armor provide comparable protection to heavy armor, enabling an extremely survivable vehicle to maintain the speeds of a tactical vehicle, deploy and maneuver quickly, enter more narrowly configured passageways, and cross bridges not available to heavy tanks? This conceptual and scientific space, it could be said, defines the Army's current modernization posture, which seems geared toward both maintaining and upgrading heavily armored vehicles, such as the Abrams tank, while simultaneously breaking new ground with composite materials and the construction of extremely survivable and deployable lighter vehicles. There may need to be a place for both, as current Army thinking might suggest.